all over a squared u plus constant. And we're going to use that to evaluate this integral. And now I'm going to come up with a problem. Evaluate the integral. How about dx x squared square root of 9x squared plus 25. Make sure we can sketch plus. I don't want to be looking like a master. Hey, I hope you find this not too bad at all because we have a formula. We're just going to go in here and let u equal to something. We just got to recognize what to let the u equal to and what the a equal to. I say we start with the easy thing. What will a have to equal? 5. All right, is that agree? I'm just going over here. It looks like we're going to let a equal 5, aren't we? You get this thing going, huh? Did anyone recognize that? By the way, does anyone realize why I would use this to solve this? Does it look quite similar? That's what I mean. You could go through this thing and solve other problems in that section. This section, I think I took 4 problems for the practice problems. But eventually you search through it, you'll find it. Now, what about the u? What am I going to let u equal to? You are good. Is that what agree? So look at it carefully. We'll say, what are we going to let u equal to? Well, over here it's got u squared, 9x squared, and what's right there? U squared is x squared. Does everyone see that there? In that problem? Well, we're going to let the u equal to 3x, correct? All right. Yeah, but we'll come back to that x later on. And the reason is because this one was under the radical. This was more complicated than this. But then in the end, you and I can figure out, well, what can we replace that x with? Because eventually, we will get everything in terms of u's and do the integrals. That's a really good question, everyone. You got the x squared here, but you have a 9x squared, and they wrote this as a what? U squared, u squared. So we're going to have to, we'll let u equal to 3x. But then we can manipulate this to a u sub to get the thing working. Okay? Because eventually we want to get this so that these are just the same. We'll get constant stuck out. So I'm going to start by letting u equal 3x. Okay. Now, what's du equal to? Well, why are we doing that? Because we want to get these du's out of here, right? So let's differentiate both sides with respect to x. What would that equal? 3 dx. Well, cool. There's the only thing we're going to have to add. I can put this what? Dx I'm going to replace with the 3dx, right? If du equals this, what's equal to that dx? 1/3 du. I just want you to glance it over. Do I have something to substitute there? What can I replace that dx with? 1/3 du. Excellent. Can I replace this radical? What can I put right there? U squared plus 5 squared, right? Is that okay with that? But here's the big challenge right there. Is when I want to get everything in terms of du. What am I going to put here? This is the big puzzle, which I think we're going to find easy to deal with. What about that x squared? What would I put there? Do you know? Well, how about this? If u equals 3x, what would x equal in terms of u? That's what we do. And when u equals 3x, right? So we can leave this as a what? A u squared? But then I'm just going to take this right here and go
1/3 squared.
Yep. I'm going to go right to the side and go, if we let u equal to 3x, what can we replace that x with And x would just equal up u over 3, wouldn't it? And I'll put it right next to it. So I can replace this for the x, true? This will just be u squared plus the 25, that's just going to be the a there, we're good there. And then dx becomes the what? The 1/3 du. All right, it's ready. But then here's my work. I just want to make sure. All this is my work. That's all we had to do to play around with this. It is now time to go back in here. We're trying to get everything in terms of u's so we can get this thing to roll into that. Right? See how it was almost close? But these were not the same earlier? Does everyone see that? We're now going to make these be the same. We're going to make them be u's. All right. So here I go. What replaces dx? Okay, 1/3 du. I'll write it like that first so people know I put it there. What's getting squared here? U over 3. We're getting all u's though. What's in here? U squared plus, well, that just stays what? Do you want to write that as 5 squared? Maybe I'll do that. I'll write this as u squared plus 5 squared. Just so when you get ready for the formula, you know this a is just a what? A 5. That'll be a 25. That's going to be a 25. You see it coming? Can you help me rewrite that, Andrew? Like get constants out in the front. I want this to look like that. So I'll put this 1/3 out here. Great call. How about this one, everyone? He took that 1/3 out in front, but what about this one? That's 3 squared, which is 1/9, but it's a 1/9 in the denominator. Ooh, can you help me with this? 1/3 divided 1/9. What the heck is that? Right, let me lower it down so everyone sees this.
3?
Yeah, so I'm going to write 1/3 out of 1/9 all in front of this integral. This has just got a nice du here. There's a 1 on top. This is just now a u squared, right? And a square root of u squared plus 5 squared, or 25. It is now ready. All we got to do is plug these in and get this. This is going to be the solution. You got it all set. But you notice what we did? We went from here to get it into u squared like we wanted. But a constant emerged in front. What's the constant? Is that a 3? I should write that. Then you get a 3 integral du, u squared, square root of u squared plus 5 squared. All right, what's this equal to? Now it's time. All right. Now we're going here. It's just giving us the solution. Let's type it out. What's it going to be? Write it out. Negative square root u squared plus 25 all over 25 and the letter what? U. Plus a constant, right? Now you can look and say, what did Professor Messer forget to write? I didn't want you to do this on the test. It's like just writing this. You're like, wait a minute, what's in front? The 3. Let me get that 3 in. You want me to go with the negative? Okay. Negative 3. I'll just put it right up there. I just want to put a big thing in front. Now, let me step away. Like you're about to turn in your testament. Did you finish? That's what I mean. Like they said, use this. With this, it's like a table of integrals, and we used it to solve this. This originally had what variable? So the last step, you've done this many times, you're familiar with this, then we have to resubstitute. That's all we got to do. Let's get everything back in x's. Right? That's what we do. So I'll put an equal sign, good call. Negative 3, leave that negative 3. What was u? So what's 3x squared? Okay, 9x squared plus 25 all over 25. What was u? U was just a what?
75.
Oh yeah. I think it's a great idea. Can we go one more step, simplify this? Good on. Rather than leave it like this, these 3's what? Cancel out, see that? So I can write this final answer as negative square root of 9x squared plus 25 all over Don't forget that lonely. But hey, looking at this problem, you know what else you can do? You might say, okay, I used that table to do that, but you also can play around trying the trig substitution. Doesn't that look like a trig substitution? But that's why I see how these are related. A lot of these were, this table of performance here, when a lot of these were produced by using those integration methods, like doing the trig substitutions, like in section 7.3. So if you wanted to play around with a problem like that again. That's what they mean by using the table of integrals. Now you can go in there and go, okay, but notice it wasn't a fast problem, was it? Because these were not the same originally. I had to kind of manipulate that, didn't I? But we did. We did be able to do that. Hey, any questions on that stuff? Oh, great, Dave.
For exams, is there any special section you want us to pay attention to, or should we just?
Great question. For this section here, once again, it's like you got to memorize all these, right? No, right. You don't memorize. But what it is, like, one of the options is, okay, you give students this, and then you give them a problem like from that section. You go, you're gonna have to look through all these to figure out which formula you got to use. That's great if you got like tons of time to sit here and look. Let me see if I can recognize that one. They kind of label them each one. My preference when I do that is to actually start a problem just like this. Use this right here to solve that problem. In the practice problems that I gave to you, I put like 4 of them. So it's not something, I don't want you to go crazy with. This section's kind of light compared to the other ones. Because it's like, oh, they're giving us a cool formula. You might have to do a little manipulation to get it going. That's what you'll find. Okay? But great question. So that way, you wouldn't have to what? You wouldn't even bring this thing in. But feel free to have this because it's something it's interesting just to look at. I mean, how many pages long is this? This is 5 pages? Yeah. So very good. But that's how I like to put that problem. I mean, that's how I like to assign the problems in terms for a test. So you know exactly what to expect. It's like he would give it to me and actually have me set it up. But it requires some kind of manipulation. Sound good? If you can do the 4 practice problems that I put for Simon, you're good to go. Any other questions? Doing a great job today. Have a super weekend.